Yeah, we got to make true statements in order to shade my region. If the coordinate makes a true statement, oops, I guess I just finished that sentence. If a coordinate makes a true statement, then it is in the shaded region. Okay, peeps, so now we need to graph this accurately. Okay, we can do this, people. All we're going to do is practice this together today. We've got an x squared function, which we know looks like a u. What's that minus 2 going to do? Yeah, this is going to go right 2. Then what's the minus 3 going to do? Down 3. Well said, Mr. Parsley. So you guys, we're going to take the u and we're going to go right 2 down 3. This is the new origin of my u parabola. That's my origin. You guys have taken care of the right 2. I've taken care of the down 3. So all I have left to graph now is x squared. You guys know how to graph an x squared. If this is the origin, act like this is 0, 0. What's 1 squared? 1. So I'm going to go up 1 from there. What's negative 1 squared? Negative times negative is a positive at 1. 2 squared, I'm going to go 2 to the right and I'm going to go up 4. Negative 2 squared is still also 4. 3 squared is going to get me 9. Negative 3 squared should get me 9 as well. But again, that's all relative to this new origin. Then, is it solid or dashed? It's going to be solid because it was less than or equal to. What's up, Livy? So now we're saying it's less than. Less than is always going to be underneath or outside, like you said. Well said, Danny Main. What could have been a point that we chose to test that, you guys? 0, 0. I'm a little leery because it's so close to the line, but I do think it's definitely under it. So I could have plugged it in, but I probably would have chosen something a little bit further away just to make myself feel more comfortable. I personally say, what did you say, Gabe? Sure, well, okay, yeah, that works. Negative 1, negative 10. If I would have done that, I would have had negative 1 minus 2 squared minus 3. I would have had negative 3 squared is 9. 9 minus 3 is 6. Is a negative number less than 6? Yes. So I would shade where that spot was, that point was, which was down here. Okay, question then. It says, hey, is 3, negative 4 a solution? 3, negative 4. What do you think? Yeah, it's in that slate shaded region, so I would just be like this, yes. What about 4, 7? 1, 2, 3, 4, 7 is somewhere inside where we didn't shade, so I'd say no on that one. What about negative 1, 6? Yes. Yeah, it's on the line. Are we allowed to be on the line? Yes. How did you know that? Because it's or equal to. Very good. It's included. If it was a dashed line, this would not be a solution. But because it's a solid line, we can equal that line. So we're going to say yes. How about this one? What's this parent function going to look like, you guys? Oh, thanks, Worcester. He says it's going to be this little x cubed. Where's this cute little x cubed going? Right 1 down 2. I love it. Right 1 down 2. Right 1 down 2 is the origin of my x cubed graph, you guys. That's my new origin. You got this. We're not making these skinnier or fatter. What is 1 cubed? If I went 1 to the right, what's 1 cubed? 1. What about negative 1 cubed? Negative 1. What about 2 cubed? 8. So I'm going to go 2 to the right of my black dot and up 1, 2, 3, 4, 5, 6, 7, 8. Just off my graph. Solid or dashed? Dash it. I only have room for 4 points. That one even was off the graph a smidge, but that's okay. And I think shading this one's tougher. So what point do we want to use to help us figure out where to shade? 1, 1 or 0, 0. I feel comfortable using 0, 0 in this case since it's so far away. If I use 0, 0.
What point is the tall one up there?
Oh, I just went over 2 and then up 8. 1, 2, 3, 4, 5, 6, 7, 8. Because 2 cubed is 8. You down with that, GP? GP? To figure out where we're shading, if I use the point 0, 0, I would get 0 is greater than. What's negative 1 cubed, y'all? Negative 1 minus 2. Is 0 bigger than anything that's negative? Yes. So since that's true, I shade where the origin is, which happens to be here. So this V is going to go left 2. What's this going to do?
Makes it
This,
upside down.
oh yeah, this is going to reflect over x-axis. And then having that 3 out front throws some people off. So I'm going to rewrite this, and I'm not going to change anything, but I'm going to put it in a way that I think you guys are more familiar with. Do you agree this 3 is a positive 3? So could I just say +3 at the end? Yeah. So
+3?
yeah. What'd you think?
I guess because there's no parentheses, it doesn't multiply.
Right, exactly. Yep. So that's why I think rewriting it sometimes does help you guys. And so this 3 right here actually just takes it up 3, doesn't it, you guys? My 3s are looking a little sloppy. Boop. Okay. So you guys, we've got the V. That had to go left 2 and then up 3. Is it facing up or is it facing down?
Down.
It's facing down, so I'm going to do a dash line, facing down with the slopes of 1 and -1. And where would we shade? It says my Y is greater than.
Underneath.
Above. Oh boy.
In 0. Yeah. Never
Yep.
mind.
So we'd have 0 is greater than 3 minus 2, which is 1. Is 0 greater than 1? It is not, so I cannot shade there. So I'd shade on the other side.
I just.
You're up on this guy.
U.
It's just a U. Where's that U going?
Oh.
Up, exactly, because there are no parentheses. This U is just going up 1. Up 1. So I'm going to go up 1, solid or dashed? Solid. And then you guys would just have to graph an x squared. So I'd say from that new origin, 1 squared is 1. -1 squared is 1. 2 squared is 4. And that's really all that we have room for with my solid line that I'm going to put through those points. Solid. Less than means we need to shade under. If we picked 0, 0, is 0 less than or equal to 0 plus 1? Yeah. 0 is less, so I would shade where the origin is. What is this one looking like, you guys? Absolute value of x.
But it's negative.
Wait, hold on. You're looking at the next one. Absolute value of x is what shape? The V, which is going, you said it, Worcester? Left 4. V is going left 4. Is it facing up or down? Up, solid or dashed? Dashed. When it's facing up, when there's no, skinnier or wider, it just has that slope of 1 and -1. And if we're greater than, we're going to shade above it, right? Just make sure, Livy Lou, on that one. Okay. Ooh, this one's a weird one. Yeah, well, kind of. Square root. Oh, yeah, were you doing this? Okay, to me it looked like almost an x cubed, so just be careful. This is square root. This is square root, like this.
Wouldn't it be going upside down, though?
Ooh, yeah, you're saying this is going to flip it, reflect over x-axis,
Like that.
Left 2.
and left 2. Agreed. You guys, this is good.
Does it go like this or like this?
Let me see the first one. Here we go. Square root of x. You guys, we got to go left 2. Here's how we're going to graph it. You guys, the original one would look like this. Again, I didn't do that accurately, but you agree this new one's got to be like that, yeah? Here's how we're going to do it accurately. You guys, we took care of the 2. We took care of that 2, so we just have the negative square root of x left, okay? You guys, let's ignore the negative for right now. What's the square root of 1? 1. And then I would just put a negative in front of it. So instead of going up to 1, I'm going to go down to 1. Do we know what the square root of 2 is? Square root of 3?
No.
Square root of 4?
No.
It would be 2, and then I'm going to reflect it over, and I would go down 2. The next square root I would know would be square root of 6, 7, 8, 9, which is kind of far away, and it'd be -3. You don't have to put that one. Solid or dashed on this one? Dash. Good call. Thanks, people. Dash that line. And then the shading for this one is weird. Where are we shading? Greater than or less than?
Everywhere around it.
Greater than or less than? Greater than means we need to go above. Here's the deal, you guys. This graph does not exist over here. The graph starts at this blue point. So I can shade above from that blue point and that blue point only, and then above the graph. You cannot shade to the left of that origin point. No, you cannot, because the graph doesn't exist over there. So we'll shade above from starting at that origin. What shape? We got a V here, and the V is going to go right 1, and then what's that 2 going to do? Skinnier. So here's how we're going to do this, Gabe. You're going to want to listen. We're going to go right 1. We're doing the V, right 1, but we need to make it skinnier. You guys, typically we'd go up 1 over 1 when we had an absolute value. But now it's 2 times that absolute value. So we're going to go up
2.
over 1. Exactly. That's going to be like my slope that would make it skinnier. Liv, if we went up 1 over 2, it actually would make it wider because it'd be a half. You know what I'm saying, girlfriend? 2 is going to make it go a little skinnier. Dash lines, people, dash lines. And less than. Less than is under.
Yes.
Love it.
Better than a test every.
How about this one? Absolute value. And then plus 2. Up 2, exactly. This is going to take that little v up 2. What's the slope, though? Yeah, it's just back to 1. Back to the normal width. Solid or dashed? Very good. Shade above or below? Uh-oh, I heard an A and a B. Above and below? Less than is going to be below. Yep. Okay, last one. My parent function is a good old x squared. Where's that x squared moving?
To the right.
Right 1, down 2. Right 1, down 2. And we need to graph an x squared. So that would mean 1 squared is 1. 2 squared is 4. 3 squared is 9, which is going to be way off my graph. Solid line. And we need to graph less than that.